one of the things you have to do on this exam, or rather in this packet, I should say, and you will have to do on the exam as well, is they ask you what is the size, how big is this cell, right? Don't they ask you that?
Yeah.
They say, here's this red blood cell, here's this virus. I think they give you Ebola virus, and they give you a rhinovirus, which is a cold virus, right? Rhino means nose, by the way. That's why they call it a rhinoceros, because the horn is on the nose, right? So rhino actually means nose. Well, no, few people do until they learn it. All right, so if you're looking, if you know the magnification, if they tell you it's 1,000, like I think they tell you, if I remember correctly, they have a 0 magnification here, right? And then they have what? I think they got like 1,000, don't they? 1,000x, and over here they got like 10,000x. And then they got like something like at the end they have 1,000,000, don't they? If you don't know, you haven't done your homework, right? Because you should have done that in class. That's the first thing you did in this on Monday. You didn't do your classwork if you don't know what I'm talking about. Because we did this in class on Monday. We started it, and you're supposed to go online and do it. And you guys were asking me questions, and I said, make sure you get this done. Make sure you figure it out. And then you had all day yesterday, which is Tuesday. And now today, Wednesday, I'm going over it, and some people are like, I don't know what that is. Well, thank you for letting me know you didn't do your work. All right? So this is your magnification. So that little thing over here is your mag. Now there's a couple ways you can do it. You could have taken a piece of paper, right? And remember they had a look, they had the cell. They have a cell. And then they gave you a little line on the side. It's not colored, but I'll color it. And they said this is 2 micrometers. All right, that's what they say. So you can take that piece of paper, you can use it as a ruler. Take that piece of paper, move it underneath here, and then mark it. So you can take a little piece of paper and mark it. It's kind of a neat trick. And if you're on a standardized exam, if you have some scrap paper, you can use the scrap paper. Then you mark it, so you get now you know what's this length here. 2 micrometers. And you can move it over here, and if it looks something like this, if you have your paper and you put it in front of the cell, and it looks something like this, right? You put your strip of paper in front of the cell, and it looks something like, there's one mark, and then there's the other. Well, how big is that cell? What's the diameter of that cell? What is it? Yeah, like 1, maybe it's like 1.5. Those are good guesses, right? I would go for that. I'd be all right with that. And on a multiple choice test, if you said 1 to 1.5, so 1.0 to 1.5 micrometers, that'd be fine, right? And on a multiple choice exam, they'd give you A is this, B is that. Usually they won't say like 1 and then 1.5. They'll say 1 or 2. It's not 2 for sure, so you go 1, right? So you can do that. That's easy. But if they told you that this was 1,000, they said this is 2 micrometers and the magnification is 1,000, and they asked you what is the and you have an image, there's the image, and you can measure the size. You have a ruler, and your size, and you don't have this, right? If somebody does, they give you a ruler, and you measure 1 centimeter. Well, how big is, they tell you it's 1,000x, and they tell you it's 1 cent, the image you're looking at is 1 centimeter. Well, what's the size of the specimen? Can you find the size of the specimen? If I give you this, obviously the magnification is 1,000x, right? So what's the size of the specimen? Say again?
Do we have to convert it into micrometers?
Well, let's not worry about micrometers, to be clear. let's not worry about micrometers at all. Let's say we have a centimeter. You can convert it. You can convert it to micrometers soon. You can convert it to anything. This is great about the decimal system, right? Just move the decimal point. But how do you find the number? Say that again?
Just change it to whatever you want.
Well, if I were you, anytime I'm given a formula, I would inspect the formula. All right? So I know what do I know? This is what you should be asking yourself every time you do problem solving. What is it that I know? I know that the image, that's what I'm looking at. I'm not looking at the specimen, right? I don't see a yeast cell. I see an image of a yeast cell. The image is 1 centimeter. Okay. I know the magnification is 1,000x. And I know that the formula, the general formula for finding magnification is this. Well, how do I find the size of the specimen? How do I know how big this yeast cell is? Yeah.
Plug in your 1,000 magnification to the app.
You could do it like this, right? Equals 1 centimeter over, let's say x, where x equals the size of the specimen. And about this time during the lesson, somebody always raises their hand and says, why are we doing math and science? And the answer is, the language of math is science. This is how we speak in science. Yeah.
Isn't like 1 centimeter like 10,000 micrometers?
Well, let's worry about that in a minute. All right. So we solve for x, right? Which is to take x equals 1 centimeter divided by 1,000, right? Which equals 0.001 centimeters. Do you agree? And that's the easy way of doing it. I personally, and this is just a personal preference, you can decide how you do it. I like to check my work, and so I always like to make sure I rearrange the formula first. So I like to say size of specimen times m, which is magnification, equals size of image. And why do I like to do that? Because I like to make sure that I got my calculations right. And I like to verify my algebra. I like to take things one step at a time, because we can make mistakes when we do our manipulation of the variables, right? So if I start with, I'm just going to put SI for size of image, right? Divided by SS, which is size of specimen. What do? I'm going to go ahead and do SS, this cancels out. Then I'm going to go ahead and reverse it, because I know this is an equal sign. I can put it on either side, right? So I'm going to put size of image, because I like what I'm looking for on my left. That's just my habit. Equals SS times the magnification. Now all I got to do is exactly what someone just said a minute ago. I could just do equals. Well, first of all, is that right?
Yes.
Is that right? But that didn't get me what I wanted, though, did it? Because all that did was get me these two, right? It's still not what I wanted. So now I know, because I checked it, because I did it this way, I knew I did this wrong. Not wrong, but I'm not done, right? So I got size of specimen on the one side, but what do I need to do? Divide by what to get size of specimen by itself? This is what I want, right?
Divide by m on both sides.
Divide by m on both sides. And again, I'm going to go ahead and, of course, these m's cancel. I'm going to rearrange it again. SS equals SI divided by M. Now it's the same, isn't it? And what have I done when I do this? I get to cross out, which makes me feel more confident that I'm right. Because when I'm crossing out, I know I'm not making mistakes. I like to label things, like with this arrow. This is the one I'm looking for. This is the one I'm looking for. I like to follow it along in the calculations to make sure I got the right number. Because if I could have easily found the size of image and found myself in trouble, right? Because instead of putting it the number into SI, I could have put it into SS and then multiplied the two numbers together and gotten some weird, the exact opposite of what I should have gotten. So this allows me to check my answer, my work. When I'm dealing with word problems, when you're dealing with word problems, which is what science is, right? Word problems. When you're dealing with word problems, you have to make sure that you're doing the right calculations. You can do the math perfectly right, but if you're not putting the numbers in the right place, you're going to get the wrong answer. All right, so when I substitute the numbers, of course, I get the same numbers that I did before, which is 1 centimeter divided by 1,000, which is equal to 0.001 centimeters. Now, someone asked me a minute ago, what are the SI units and how... you didn't really ask that. What did you ask? You asked... What did you ask? You asked how many, what did you ask? How many micrometers?
Oh, me?
Somebody asked the question, didn't they? Didn't you?
Oh, I was like, isn't 10,000 micrometers 1 centimeter?
Isn't 10,000 micrometers 1 centimeter? What do you guys think? It's possible. Okay. You guys don't know. Is that what I'm hearing?
I feel like it is.
You think it's 1,000? All right. Well, let's go through it. And I guess I could print this for you, but let's go ahead and do this. When you're dealing with centi, first of all, let's try to break this down. You have these units of measurement, right? You can have liter. They're basic units, right? SI base units, what we call base units. And SI base units are, for length, is what? What's lengths? International units. Everybody in the world agrees that the measurement, the base unit of length is what?
Meters.
Meters. We all agree. In the United States, people use feet. It's an imperial after England. England actually came up with this. People blame America, but you can blame England. It's the king's foot was a foot. And the king's thumb from the knuckle to the tip, that was an inch.
What was the centimeter? His nail?
There was no centimeters at that time. That was the length. The king was the gold standard. We don't do that anymore. We have this meter stick that's in, I forget where it is, but it's the perfect meter, and that's what everything's measured by. That's our standard. So what about mass? What do we use for mass? You would think it'd be, you would think, but it's actually kilograms. This is what everybody's going to start with. If you measure mass, they're going to ask for kilograms. Why? Because you're talking about a human being. But you could look at gram as the base if you'd like. That's fine. Time. What is it? Internationally, what do we use for time? The world uses what for time?
Hours.
Seconds. The base is seconds. Temperature. How do we measure temperature in SI units? Kelvin.
Oh, yeah.
Kevin.
We use Kelvin. Yeah. Now, well, Celsius is the standard. Standard, it's either Celsius or Kelvin. Usually we do things in Celsius because Kelvin's a little crazy to do some calculations. Yeah, it's based on absolute zero. Hey, can we stop talking? Yeah.
So, I told my mom I wanted to be frozen at negative 230 degrees Celsius. She said, "Will you be okay?" I mean, are you sure you'll be fine?
Why did you,
Don't worry.
please inform your colleagues, hold on, before you finish the joke, please inform your colleagues what you mean by negative 273 degrees Celsius.
Negative 273 degrees Celsius is 0 on the Kelvin scale.
So when
So
you,
I said I'd be
zero, when you're looking at Kelvin and you see 0 for Kelvin, hold on, 0 in Kelvin is negative 273 degrees Celsius. So obviously water freezes at 0 on the Celsius scale. So this is actually absolute 0. This is where all matter stops moving. Remember the whole discussion on osmosis that all matter moves? Well, this is absolute 0. And in Kelvin, it's negative 273 degrees Celsius. It's actually some decimal. The formula for Fahrenheit, you have to divide and multiply. I would rather not deal with it right now, but we could figure it out. You could ask Siri. It's really easy. The formula is not really difficult. It's just, guys, it's added time we don't have. So we're not going to spend time going through that. So that's temperature, amount of substance. If you want to figure out how much you have. So if you want to figure out concentration or anything, what do you think we're going to use? Something called moles. And if you want to know how bright something is, we call it luminous.
like the Harry Potter spell.
Yeah. That's where writers get their stuff from their science classes, mostly. Just so you know.
And a whole lot of it is
All right, we call it candela. Yeah, candela. Candela is just from a candle. Luminance intensity, yeah. How bright something is. Often you'll see, hey, excuse me, I'm not done talking, so stop putting stuff away. I'll tell you what, I can have you come after school, we can discuss it. Other than that, I'd like to see your face and I'd like to see you listening. So, in flashlights in America and most places, we actually measure something called lumens. We don't use candela. But internationally, we all agree that candela is the base unit. Now, the other thing is that when someone asks you what micro means, well, micro is 10 to the negative 6, not 10 to the negative 3 meters. So that would be, this is a symbol for micro, by the way, 10 to the negative 6. Centi, which is what you have here, centimeters, is 10 to the negative 3. So this is actually equal to 0.001 centimeters. How many meters would that be? That's 10 to the negative 3 centimeters. For every 1 meter, centimeters canceled. Do you see how I made sure I set it up that way? Then when I divide, what do I have? I'm sorry, it's 10 to the negative 3 meters. I messed that up. 1 centimeter is equal to 10 to the negative 3 meters. So what is it? 1.001 centimeters is how many meters? 0.000001 meters. Who could follow that? Who follows that? Some people say they can follow it. All right. I'll finish this in a video and you'll have to do it on video. And I'll have this printed for you as well. Have a good day. Well, I'm going to repeat this again at this point so that we're all on the same page. SI units. SI units are it's the international system of units. And why is it SI not IS? Because it's in French. It's systemic. I don't know how to pronounce it in French, but it's in French, and as in most Latin-based languages, the grammar is reversed from English. Does that make sense? You'll learn that when you take Latin next year. Some of you are taking Latin now, but you'll learn it, most of you will learn it next year. So in Latin, the grammar's opposite. So in any case, SI units, International System of Units. And there's these things called base units. This is where we're going to start. All the countries of the world got together. Or I don't know if it's all the countries, but most of them anyways. They got together, certainly the Western countries. They got together and they said, huh? Could you go spit your gum out? Do me the favor and spit your gum out. Thank you. So you have base quantity. So you have a base quantity. So there's going to be some kind of base unit that we're going to pick for each and every quantity. And one quantity is length. Who knows what the length base unit is for length? What's the base unit for length? Meter. That's right. Most people should know that. It's not a foot. Somebody said a foot this morning. A foot is what we use in English. It's the British system. It's called the imperial system because it was the empire, the British Empire. It was actually the foot of the king was how they first measured it, right? And did you know that an inch was the thumb of the king? From the knuckle to the tip, that was an inch. That doesn't really work very well, right? If you got a big king, you got a big inch, you got a small king, you got a small inch, and then what are you going to do? You know, it's going to cause all kinds of issues. So we standardized it, and it's something called the meter. Of course, you could standardize an inch. It is standardized. We know that the inch is standardized, but we all agreed, let's just do this meter, because the interesting thing about this SI units is that it's based on the metric system, and the metric system is much easier to use because you're just using decimals. You're moving it one way or the other by a factor of 10, so the decimal just gets moved right or left. Easy, right?
Yeah.
So length is meter. Mass is what? Kilogram is correct. Now, this is confusing because it really, to me, why not gram? Why kilogram? I don't know. There's probably some history there, but we'll just leave it alone. It's kilogram is the SI unit. What about time? Minutes a good guess. It is seconds. Happens to be seconds. It could have been minutes, but seconds is the base unit. Electric current. A volt is a really, really good guess, except that a volt is about potential. So volts measure electrical potential, the difference between the two sides. Joules is a measurement of energy. Watts is a measure of power. Each of these is slightly different.
So what is it?
It's what? It's called an ampere.
Oh, amp? Oh.
It's an amp. Yeah, ampere is an amp. That's a measure of current, how much electricity is flowing through at any given time. It's an amp. Here, we call it an amp. Each of these have symbols. We have M, kg, S, big A. All right. Temperature. What about temperature? How do we measure in SI units? What's the base?
Celsius.
Everybody says Celsius. I agree. I would have said Celsius too when I was your age. Not Fahrenheit. Oh no.
Kelvin.
Yeah, it is Kelvin. Fahrenheit is something we don't even say that. I don't even say that word in a science class. Kelvin. Honestly, it would be so much easier if we in America would just agree to do the metric system and just end our nightmare. But we just don't. We're stubborn. But it's not an American system. You understand it's a British system, right?
Yeah, can you keep them
We just stuck with it while Britain turned their backs on it. You know, they came up with it, and then they left us alone. Same thing with soccer, by the way. The word soccer was developed in England. They came up with the word. But then everybody said, let's call it football, and England said, sure, why not? And we said, no. They stay in soccer. We have American football. Yeah. Say what?
Soccer is football.
Duh, that's what we
That's what
saying.
he just said.
But in America, it's not. In America, we have something called football.
Wouldn't that be handball?
All right. So moving on, even though there's some kids that want to distract us, and plus I'm not. Amount of substance. What if you want to measure? We talked about this, didn't we? We had amount of substance, and actually on the test, you actually saw this unit, even though you probably didn't even know what it was. Amount of substance. If I want to put the amount of something and it's not mass and it's not volume, because I didn't use volume, right? What would I use?
Cups and stuff.
ounces.
Amount. I said it's not volume.
Is this space that takes up?
Area.
Moles.
Okay, I don't know.
What is the mole?
I don't know.
It's you would know.
You said same.
It's 6.02 times 10 to the 23rd of something.
Okay, yeah, that's a.
It's a lot.
Yes.
A mole is a lot. Right? 10 to the 23rd. So imagine a number that's 6, 0, 2, so that'd be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That much is something.
That's how much they measure. And the point of
Now, does anybody really want to try to figure out how much that is? I can't even imagine it. It's a lot. It's a lot. It's not too much. If you think about it, it's not too much. Like, how much water, how many water molecules is there in a glass of water? A lot. Some factor of this, right? If you wouldn't want to use any other unit except for a mole if you're talking about something like how many atoms are in salt. Well, you have to use a big number. So this is our big number. And there's a whole story behind it and how it came up with it. And there's even a mole day in the year. We'll talk about it.
Does that
But
have anything to do with the animal world?
no. Interesting question, yeah. It is not the mammal. This is the unit of measurement, mole. All right. So these are the units that we use in science. Now you might ask, well, what about something like volume? Well, volume is one of these things that we call derived units. Derived units are units that we calculate. So volume, if you think about it, those are in geometry. Who is in geometry? Yeah, there's one person in geometry. She's on the spot now. So derived units, if you think about what volume is, and I always have trouble drawing these out right. Let's assume that that's actually a cube, which is obviously not some kind of rhombohedron thing. And you want to know how much volume is inside this thing.
it's time to go.
Is it already?
Yeah.
Oh well.
You gotta measure the inside of the view and you also have to measure how much water.
Well, think about what derived is, and we'll talk more about it. And tomorrow, watch those videos, take notes on it tonight. It's going to be taking about 10 minutes, maybe 20 minutes. And make sure that you're able to know what a microscope is, so when you're doing it tomorrow, you're not breaking the microscope. They're very expensive. Thank you.